Hi, my name is Soma. I work in autonomous driving. I've been working in this industry for the last 6 years, and I currently work as a software architect for automated driving functions at ZF, and that's my role. That's an interesting question. So when it comes to self-driving cars, there are basically two different aspects, two different approaches to self-driving cars. One is the level 4 self-driving car, which takes the human out of the loop. At this point, it exists mostly as robo-taxis. That's the plan. And that is the one that will have a very interesting impact on the existing society. And then the other aspect is the level 2 systems, which are consumer products which people can buy in the end. This will have the same impact as it has right now, but with respect to the robo-taxi services, the most interesting thing that it's handling is the fact that on average, people today, they use their car for 10% of the time, and 90% of the time it just stays idle in a garage or a parking lot or something like that. And with parking prices and everything, it's a lot of expense. And major cities have up to 20% of the space in the center of the city that is allocated for parking. There's a lot of space wasted. And also when people drive, they usually drive single person in a car that can have a capacity of 4. So there is a lot of efficiency wasted when personal car ownership. And what I think robo-taxis specifically are solving is the fact that these cars can run 24 hours a day, and they make it easily accessible for people, and they also have the cool factor, so which kind of attracts more people to use it. And I think in the net effect is that we will use cars more efficiently than we are using right now. We might have lesser need for parking spaces, and we also have the advantage that these cars can be connected together with some type of hive mentality. For example, you always know where the next parking spot is. You don't have to search for parking spots anymore. There are lots of advantages that kind of add on top when you go to this level of autonomy. And that I think is a very interesting impact. Right. There are a lot of technologies that are crucial for autonomous driving. When it comes to autonomous driving in general, we kind of split the functional aspects of this into 4 components. You have perception components, which is basically sensing the environment and creating a model of the environment. So there you need sensors like cameras, radars, lidars, ultrasonics, and so on. This is an area of its own. It's one of the biggest areas. And then you also have a prediction component, which is predicting what the different agents in the environment are going to do. This is a very, very tricky thing to do. It's very difficult to predict if a pedestrian is going to walk until the edge of the road, and then is he going to cross, is he not going to cross, or sometimes they try to cross and then come back in. It's a very difficult prediction to do. So there is a lot of guesswork involved. And then comes the planning part, which is what trajectory should the vehicle take. It's a planning. And the interesting thing is that based on what we plan, there will also be a reaction from somebody in the environment. So there's a feedback loop involved. This is something that's very tricky to solve, and there's a lot of additional technology needed to solve this. And then the last part is it's controlling the vehicle, but I think that is a solved part. Whatever I spoke right now is just about the autonomous driving function itself. This whole thing again goes into operating system, which goes into hardware, which goes into an infrastructure element. So there's actually a lot of technology involved, and there's a lot of opportunities for other industries to work together with automotive companies because of this. The thing is that there are 2 different approaches to autonomous driving, as I said earlier. One is the approach where we make self-driving cars as a service. So, which is basically robo-taxis. For example, you get an app, something similar to Uber, you call for a cab, you get an autonomous car, it picks you up and it takes you to the place where you want. There's no ownership involved, it's a service. And the other is you own the self-driving car, right? Both of these 2 things have a very different set of obstacles to adoption. When it comes to autonomy as a service, it's something that's completely new, it's fresh. And you also want this to be at a higher level of autonomy because you want it to drive without a driver, and that means it's at least level 4, right? So there the challenge is mostly is to an extent technological, but the technological aspects we kind of have a rough idea of how to solve it now, because you can put a lot of money into the sensors. And then there's also the legal aspects of things. There's also the ethical aspects of things which need to be solved in that particular domain. Coming back to autonomy as a product, where you buy a self-driving car, it's an entirely different approach, because if you make a small back-of-the-envelope calculation about how much a person would be willing to spend on a self-driving car, you will come up with a number depending on average wage and how long he will use the car and so on. You will come up with a number of somewhere around $10,000 to $15,000 that you can charge for this autonomy package. Anything more, there's no value for the end customer, so people won't buy it. So the challenge with autonomy as a product is actually keeping the price down and still increasing the autonomy level. At this point, it's stuck mostly at level 2. There are some people going to level 3, but it's not very profitable right now. So the pricing is a big challenge for level 2 and consumer product autonomy, and the legal framework and ethics and everything is a bigger challenge on the other side. That's a very, very interesting question. It's very important for OEMs that people trust the cars, of course. And some of the things that they're doing is they're actually improving the visualizations of the car's perception. They're showing whatever the car is seeing in real time, so that the driver or the passenger actually has a feeling that the car is seeing everything, and it kind of gets a sense of trust. That is one aspect of things, and I think the other things will come over time. So initially, level 4 is operating initially in like specific targeted places in the world, which is like very highly mapped, and chances of things going wrong are very less at this point of time. And the only real way to build trust is to perform optimally over a longer period of time, and then the rest will automatically happen. That's the approach. No, it's not the only way, but it definitely helps embracing technology. So the automotive industry in general has had a lot of special rules that were applicable only to the automotive industry. Because of how big it is, it had, at least in the past, it really did not. Like you had like really agile software companies, and then you had automotive companies which were trying to be agile but could not really keep up with the startups and so on, for example. But now this is really changing, because software is one of the most important things that people look for in buying cars, and they no longer want like really bad HMIs and really bad user experience in a car, because software is such a fundamental part of it. And now you see a lot of OEMs ramping up their software hiring and so on, and they've also started to collaborate a lot with startups, which has been pretty fruitful so far. Right. The short answer is it's difficult to have a unanimous solution to the trolley problem, because it's something that's related to morals and ethics, and this is considered differently in different parts of the world. My opinion is that there should be no one single company or entity that takes this decision, but rather it has to be decided at a more global scale. There are many versions of this trolley problem. One of the more popular versions is if the car has to choose between colliding with an old grandma and a young baby, which one would the car choose for, and so on. There's been some interesting surveys done on which the car should save, for example, and the results were pretty interesting. For example, in the case that I just mentioned, they found that many of the Western countries preferred to save the baby, and many of the Eastern countries preferred to save the grandma. and it was a very strong difference of opinion. There are multiple variants of this as well. For example, there's another variant of this ethical dilemma problem where if a collision is about to happen, should you put more effort into saving the passenger or should you put more effort into saving the pedestrian? Which, of course, you'll try to do both, but in case you cannot, what would you optimize for? And this is something had an interesting result as well. Like, for example, China strongly favored protecting the passenger at all costs, and Japan strongly favored protecting the pedestrian at all costs. I mean, these countries are not even geographically far apart, but they have entirely different opinions. So I think the net effect is that in the future you will have countrywide ethics for autonomous driving, for artificial intelligence, and they would probably not try to answer questions at a minor detail level, but probably try to answer ethics at a bigger level of details. For example, you might come up with a priority of things that are important. That might be the future, and I think it might be initiated by the autonomous driving companies, but it will eventually have to be decided by the governments of the different countries. The second question is easier to answer. When will we see self-driving cars on the road? It's also a question I get a lot. So there are two answers to this. The thing is, if you're talking about when can I ride a self-driving car, then you're talking about autonomy as a service. That would be in another 2 or 3 years with so many companies working on it. But of course, it's not going to be a global launch. It's going to be a geographically isolated launch. So some places in the US, some places in Europe, for example, will have autonomy as a service. But if you're talking about when can I buy a self-driving car that is fully capable of driving itself, then we're a little far away because of pricing and scalable tech and so on. I would say 8 to 10 years is what we are looking at for things that you can buy. Going back to your first question about who will win the self-driving car race, I don't think there is going to be one clear winner that takes care of everything, because the field is so huge and the complexity involved is so huge that it's unlikely to have one single winner. But what I see happening is that when it comes to autonomy as a service, you will have certain companies that are good in certain regions because they tend to have more data from those regions. And for example, you might have Google that's really good in the places that they have explicitly trained for, because they train for all over the world, but they of course train specially for that. And you might have Voyage doing something else, you might have Cruise doing something else. So there's no clear winner, in my opinion. You'll always have multiple people better at multiple things. But the clear winner in the end would be the consumers, because you will at some point have to have some sort of standardization, and competition is always good in this part.